Over the last few years, we've been on quite a journey working on a new set of capabilities, really a whole new product line at HostBridge that we refer to as Integration Analytics. I'm going to give you a brief update on that and show you what's new. We're kind of euphemistically calling it 2.0 because there enough things have been going on under the covers that we really want to give you an update to everything that we're doing. The theme of kind of this last turn of the crank, this last set of updates, is really represented by these two words, deeper and wider. And I'll explain exactly what that means. But again, just to level set, what HTAC is essentially a flashlight. It is a tool to allow you to see how all of this activity coming at CICS, at your mainframe, what it's doing, what are its performance metrics. And frankly, we've had our customers, some of which on this are on the call, use HTAC to solve a number of different problems. We've used it to spot the need to apply various bits of IBM maintenance. We've used it to find very nefarious RPA platforms. We've used it to solve many, many problems already in its short life. But again, just to reinforce, the HTAC software that runs on the mainframe and under CICS, its number one job is to grab little bits of information about that request. We refer to it as the metadata regarding the request. And we cause that data to be saved as part of the SMF 110 record in a very normal, fashion like any other bit of data added to the SMF data. It goes in as the origin data field. Then that data gets transported down to Splunk. We use Splunk because most of our customers have it. And then from there, it keeps wanting to advance there. Then from there, we do all sorts of analysis. But again, the key thing here is enriching and analysis. Lots of different ways to transport the data down. Now, while the product can be used to solve many problems, we have used it quite successfully at many different customers looking at this use case where people have used, or organizations have used various devices out here on the left side of the diagram to use terminal emulation and screen scraping to achieve some sort of automated business process. Now, everyone on this call is a HostBridge customer. You have probably HBJS, and so you are well acquainted with why all of this is inherently a bad idea and why doing that automation on the mainframe is far more cost effective and far more performant. But there are a lot of organizations on planet Earth for whom this style of detailed, highly intensive interaction between something outside the mainframe and CICS, that is what they do 7/24. And what HTAC is helping them see is why that is suboptimal, inefficient, and costing them far too much. Now, one of the things that we've done over the last few months is we worked with a particular customer where all of their transactions occurred under a single transaction name. Now, from my last presentation, you know that one of the things that we do as we observe these patterns of robotic processes, we create what we call a DNA, kind of right over here. Well, you'll notice that if all the transactions are named the same, in this case, DIMS, and all we know is the AID key, well, it tells everyone more than we knew, but it's not exactly a big revelation. And so after seeing a couple of customers who had transactions styled in this way, we decided to go ahead and add support in version 1.16 for some other elements of information. Particularly wanted to add information about the BMS maps that are being used for both input and output. And we also, we had a customer who said they really needed to know the program name performing the BMS map operation, so that would tell them more about the pathway. So as a result, the DNA that we're now displaying within the tool is much more replete with information. Now, don't worry if that looks a little cryptic. I'm going to explain exactly what that means. So if you were to look at that right now, what we know about each one of these interactions is a lot. For example, we know that in that highlighted line right there, we know that the DIMS transaction was run, the enter key was pressed, the resulting the output map that was sent was something called term MA3 and a map set term MSM, and that that send map operation was performed by a program term DI, and that *2 means that it happened twice in a row as part of this robotic sequence. Now, the fun thing is, once we begin to show customers this enhanced DNA, it really makes it easier to spot inefficiencies. And it lets us kind of play some what-if games. So one of the things that the customer said, hey, that DNA looks pretty suspicious, particularly all those clear keys. And so we said, okay, well, let's break apart all those clear keys and look at this DNA just a little differently. And when they looked at this, that's, as we call it, the jaw hits the table moment, where they go, uh-oh, I see a problem. And here was the problem. This sequence of interactions is being driven at kicks, or 2 kicks, virtually 7x24, just like a drum beat. Now, it's coming from a typical web UI or RPA platform, such as HATS, UiPath, or LegaSuite. And clearly, it's obviously using emulation and screen scraping to achieve integration. Now, all of us on this call would understand for obvious reasons why that's a bad idea. But there's a lot of this that's still going on in the world, a whole lot. Now, on that particular platform, that sequence of operations is really controlled by 5 small macros. And so they've tried to write these macros in a very structured way, and kind of with a mentality of having a main program and some subroutines. So a main macro invokes the smaller macros. But here's the catch. The macros are written to be good citizens and defend against bad citizens. And so what do? The first operation each macro performs is a clear key to ensure that they know on what screen the process will start it. So they're trying to defend against another macro leaving the session in an odd state. Well, they also want to be good citizens. So what do? Well, the last operation they do is clear the screen to leave the kicks app at a known state. Now, the catch is they do this even if the macro only runs a single transaction. So what is the net result? Well, the net result is down here. And that is that through this analysis, we were able to clearly show that there are more unproductive interactions with kicks than productive interactions. Let me state that again more concretely. Their overall transaction load, the number of transactions they run within any given period of time, is 50%, 50% higher than it needs to be. And that's because a very well-intentioned, someone with very good intentions, but using terminal emulation and screen scraping to achieve integration, wrote a set of macros, never understanding the cost on the back end of all of those needless interactions with kicks. Now, that's what we mean by we've enhanced the product to go deeper. We're also enhancing the product to go wider. And by wider, we mean go beyond just really detailed analysis of 3270 sort of connections. We now want to focus on HTTP connections, MQ, CTG. And the diagram changes, but it's still very similar. And that is, there are a lot of use cases in the world where some sort of a program out here uses something like CTG to send in a request. But in order to accomplish the business purpose, they don't just send in one request, they send in dozens of requests back and forth. Now, of course, what this does is every time a request comes in, a new mirror transaction is started in order to run that program. And the fact of the matter is that sometimes, starting a transaction is fast, or we view it as fast, but it's really work under the covers. And there are times where the overhead of starting the transaction is actually greater than the time spent actually doing the work. So we are enhancing HTAC to be able to analyze and look at this flow right here so that we can add that to the data we send down to Splunk, and so that we can analyze it for efficiency. In some cases, we can envision using HBJS as a much more efficient way to achieve that degree of integration. Again, the theme is very similar. When you do automation outside the mainframe, it doesn't matter if it's coming in via 3270 or something like CTG, there is a chance of spending a lot more energy under the covers of CICS than is necessary to achieve the business purpose. The HTTP diagram looks very similar. There are many organizations. We were looking at a top 10 bank, data from a top 10 bank this past week. They have a non-mainframe platform, a big Java app server running outside the mainframe. And what it is doing is sending in lots of HTTP requests to run individual comm area programs. Well, that was probably a good idea maybe 10 or 20 years ago, but as they've scaled, what happens is that they now have millions of these requests flowing in. Now, here's the catch. This platform out here is, again, doing orchestration. So instead of sending just one request in, they have to send in dozens of requests, each one running under its own mirror transaction, and each one requiring data conversion from XML to a COM area or to a copybook structure, and then back from the copybook structure back to XML. So we are enhancing HTAC to also be able to grab some metadata about these activities so that we can send that data down to Splunk, assess the cost, and help organizations understand those cases where they would be in the money to do the orchestration on the mainframe via HBJS. Speaking of remediation options, it's been kind of fun to continue this journey with our customers. What integration analytics has shown and revealed to customers are a lot of things. So, for example, the need to do perhaps some tuning. It's also highlighted for some of our customers the need to refactor some of their applications and do a bit of modernization. Of course, we're also always pleased whenever integration analytics highlights the need to use HBJS to up their integration game. But sometimes what integration analytics shows is just simply a need to change the business process or to communicate more precisely within the organization. I think I may have told this story last time, but one of our HTAC customers through integration analytics saw a particular pattern of interactions that was happening many times every day. And so we actually theorized that they could solve this problem using HBJS. And our customer kind of chuckled and said, no, I can solve that problem in one phone call. because clearly that end user doesn't know that we retired that RPA bot about a year ago, and all they have to do is when they come in the morning, get a particular PDF off of our internal internet server. So sometimes it's just about adjusting the business processes or communicating better, but it all starts with enhanced visibility so that you on the IT side, on the mainframe side, can see what's really happening.